All right. This is Unit 8, Electric Fields and Gauss's Law. Okay, this is where we start with calculus-based E&M. I'm going to go through it pretty quickly. The first section here is talking about static electricity. This is just a review from what we did at the beginning of the year. Um, and you'll notice that you have these two spheres that are initially far from each other, right? When you bring the negative rod near X, then it draws out those positive charges, the opposite sign charges towards the rod, and then the like sign charges are kind of repulsed from it, so they go away from it, right? Y hasn't seen anything yet because it's far away from X, so we're not inducing any charge or anything like that. When we bring sphere Y in contact with X, this becomes one unified system. And what happens is your positive charges stay over here next to the negative, okay? And then the negative charges would actually realize they can move further from the rod by going into sphere Y. So they're going to go into sphere Y because they're connected now. They're a unified system. And so when we separate the spheres, Y is going to take all the negative charges with it as it goes away. The positive charges are still over here attracted to the rod. And then the negative charges are just going to equally distribute themselves throughout the Y sphere because it's far away from the rod. It doesn't feel any effect from it. And then when we take the negative rod away, what's going to happen is, again, the charges are going to go back to being equally distributed, and nothing really happens with Y because it already was really far away from the rod, so nothing really happened with it. Okay. Okay. We've got three metal spheres. Okay, sphere X has 8 units of positive charge. When we bring Y to touch X, these charges are going to split equally because the spheres are identical. You'll see later, I think in Unit 9, where it's not always going to be a equal split of the charge. Okay. So they get the charges equal. When we bring Y away from that, okay, then they both are going to keep their 4 charges just chilling with them. Okay. When we bring Y in contact with Z, they split those 4 charges equally because they're identical spheres. Okay. When we move Y back, it keeps those charges with it. Z keeps those charges with it too. And I should have drawn this too. X still has its 4. Okay, it didn't lose its 4 at any point in here. When we bring sphere Y to touch sphere X, they're going to share the 6 total charges between them. So they should both end up having 3, and Z still has 2 over here. Okay? And then when we move Y back, X keeps its 3, Y keeps its 3, and Z keeps its 2. Okay? Okay. Okay. This is another case where you have, okay, you've got metal sphere X, which is far from sphere Y, which is near sphere Z, so Y and Z are near each other. Because they're near each other, what's going to happen is that the negative charges on Z are going to draw the positive charges on Y closer to it, and then the negative charges away from it. Okay? I guess it should actually be 4 positive signs because it should be equal magnitude, right? But not a big deal. If I connect a wire, this is basically a bridge. This is connecting the two of them. So what's going to happen is the negative charges are going to go through the wire, and they're going to then equally distribute themselves on X because X is far away from Z. Okay? These positive charges are still basically held in place towards Z. When we take the wire away, those negative charges are still hanging out there. Okay? The positive charges are still here, so nothing really changes here. Okay? And then when we take, but now these negative charges can't go back to Y. And then when we remove sphere Z, you're going to notice that these are going to end up being, you're going to have a positive charged sphere on Y, and then you're going to have a negatively charged sphere on X. Okay? All right. Pretty straightforward. This is talking about electroscopes. Okay? Electroscopes are something that we covered back when we first did electrostatics in Unit 2. Okay? When the electroscope, remember that it's basically some container that has that has leaves inside the container, and then outside the container there's something that can, uh, uh, like usually like a ball or something. Okay, um, and it needs to be some sort of conductor that allows the charges to move really easily. If it's initially uncharged, right, that doesn't mean that it has no charges on it. That just means that it may have that it has an equal distribution of charges. There's an equal number of positive and equal number of negative charges, and we're not really like drawing out any one charge. When we bring the positive rod near the ball of the electroscope, you're going to notice that that brings all of our negative charges up to the ball of the electroscope, and our positive charges down into the leaves. And because these two have like sign now, that's why they repulse each other. Okay, they push each other apart. When somebody who's grounded touches the ball of the electroscope, so maybe they didn't do their physics homework or something, right? When somebody is grounded, okay, and they touch the ball of the electroscope, what happens is that the positive charges realize that they can get further away from the rod by going up through the ball and through the person. So yeah, they are willing to go up near the rod as long as there's another path for them to go to get out, right? To go even further away. So our negative charges are still going to be hovering right here at the ball, and our positive charges are going to go through the person and to ground. And when they go to ground, they go into the earth and equally distribute. And the earth is basically a giant sphere, right? So they're, if we've got 4 charges, that's a lot of space for them to go in, right? The person will then remove their finger. Okay, so he basically siphons all of the positive charges out of the system. Okay, and then you'll notice too that when the rod is removed, those charges will then equally distribute themselves throughout the system, and then these two leaves have the same sign again, which is why they're still separate. Okay. So you'll notice that they initially separate here, then all the positive charges are gone, so they come back together, close, and then because the charges are now equally distributing themselves, they're going to now separate each other because they have the same sign. Okay? All right, that is just the intro to electrostatics. Okay?